Welcome to a tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion of different past paper questions that have been asked in AQA physics. This is paper 2, electricity. So we are going to see how you approach the questions and what's the best way you can be able to present your answers in order to earn all the marks. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. Also, if you can be able to join our Patreon page, you'll be in a position for you to download the PDF that I'm presenting at this given point. So let's dive in so that we can be able to get started. Right, so we are told that name the material used in the structure of a plug. Give the reasons why each material is used. For the pin, this pin has to be a material which is a good conductor and also a material which is strong, so we can be able to say this is a brass. And the reason we are going to give the usage why it's used, because it is a good conductor. It's a good conductor, and at the same time it's strong. Yeah, so next part is the outer case. Remember, the outer case has to be a material that is an insulator. So in this case, we are going to go for plastic. And the reason we're going to say it because it's an electrical insulator. Yeah, it does not transfer electricity, so that is going to prevent the users from being electrocuted or from getting an electrical shock. Now, the 3 pin plugs contain a fuse, which wire inside the cable is the fuse connected. Where is the fuse connected? The fuse should be connected in the live wire, because that's where current is flowing. And what effect does current through the wire have in the wire? The fuse is a thin wire, so when current is going to pass through the fuse, what you're going to realize is that that wire is going to melt. Yeah, so for once the current is going to pass through the fuse, because a fuse is just a device which has a thin wire, and when current passes through it, the fuse will be hot. Yeah, and then it's going to melt. It's going to be hot, then eventually it will melt in that particular case. Then now let's see what is the next question here. The power of the washing machine varies between 0.7 kilowatts to 2 kilowatts depending on which part of the wash cycle is operating. Calculate the maximum current drawn from the electricity supply by the washing machine. So we know the concept that power is equals to what? Power is given by current times voltage. That's the formula for power. Then if we want to work out the maximum current, it means current is going to be power over voltage. So for us to have maximum power, it means we must have power maximum. Then this means that for us to have maximum current, we shall say power must be maximum, which is going to be 2000 watts divided by the current, which is 230 volts. So if you take this and then we divide by calculator 2000 divide by 230, we are going to get our answers 8.70. We shall have 8.70 amperes as the current in this particular case. Yeah, so that is exactly what we are going to have. Then now we can be able to move to the next part of the question, whereby we are told that the figure shows how the mains electricity cable is connected to the washing machine. Yeah, so that is it. The statement is well indicated here. We have the mains electric cable, we have the earth, we have the neutral wire, and then we have the live wire. Then if a fault makes the metal case live, the earth wire and the fuse inside the plug prevents the mains cable from overheating, causing the fire. Explain how. So first, this is intended to break the circuit. For instance, we are going to say the wire in the fuse is going to melt, because when current passes through the thin wire, it's going to get hot, and when it heats up, it's going to melt. So the wire in the fuse will melt, will overheat. Let me just put it properly. Will overheat and then melt, and then melt. And later on, it means that all the, and this is going to reduce the any cause or any chance of a electric shock. This to break the circuit, to break the circuit. And current from the live wire will be connected to the earth. Through the earth wire, because that's why now we have the earth wire, and then we have the fuse, so that we can be able to reduce chances of electrocution. So all this prevents fire and electric shock. Yeah, so basically that is exactly what you ought to say whenever you are given a question like this in an exam. So further, we are being told here that new research has shown that many people underestimate the hazard of using mains electricity. It's important that people do understand the hazard of using mains electricity. Suggest why. Suggest. This will reduce the chances of electric shock, because people will not be careful if they don't understand how dangerous this is. Looking at question number 2, use the correct to complete the set. Electric current is the rate of flow of what? Electric current is the rate of flow of charge. Electric current is the rate of flow of charge. 3 wires of the 3 core cables have different colored covering. Say the color of the neutral wire. The neutral wire is usually blue. Looking at Roman 2, which two of the plugs shown above protect the wiring in the circuit? Of course, here we're going to talk about the earth wire, reduced chances of being electrocuted, and then we have the fuse, which is going also to melt in the process when there is short circuiting or there is excess current that it flows. What does double insulation mean? Yeah, double insulation. This refers to insulating, yeah, or covering and the outer part of an appliance by non-conducting material. Now, sometimes you'll find that different appliances are covered fully. For instance, if you go and look at the way the fridge is designed, the entire part of it is covered with plastic. All a water dispenser, the outer part is covered with plastic, and this is meant to prevent any contact with the circuit inside that particular appliance. So the phenomenon or the situation whereby an appliance is covered by plastic or an insulating material on the outer surface, that is meant to prevent any contact with the wires within that particular appliance. And these kind of devices which are under double insulation, it will mean that they should not be having earth wire, because already they are covered. Even if the person touches that particular appliance, then the person is not going to be electrocuted. State which of the three wires is not required when we are having double insulation. This is the earth. When a material or when an appliance is having double insulation, it means there's no need for you to have the earth wire. Yeah, electrical appliance is connected to 20 volt supply. The current is 3 amperes. Calculate the power. We have said from the previous section that power is equals to current times voltage. So in this case, we are going to say, in order to work out this, we are going to say this is going to be current is 3 amperes and the voltage is 20, which means this is going to be 60 watts. This is going to translate to 60 watts, and now this will make us to move to the next part here. Then we are told another electrical appliance is connected to 20 volt supply. The appliance transfer that 300 joules of energy. Calculate the charge. We know that charge is equals to current times time. Okay. So we can be able to approach this from the fact that energy is equals to voltage times charge. We can be able to approach it that way. I wanted to use this, but because we don't have time, we can be able to say that energy is equals to charge, which is QV, right? Then our charge in this case, because we are working out the charge, we can be able to say charge is equals to energy over voltage, isn't it? So which means that this is going to be 300 divided by 20, and if you can be able to work it out, you are going to get this is translating to 15 what 15 columns. So this is 15 columns. Yeah, so the main formula that you ought to remember is this, that charge is equals to energy is equal to charge times voltage. Then if we make charge the subject the formula, we can be able to apply that. We are having a radio here which is connected to two cables. What must be fitted to the cable before it's connected to the main supply? What should be connected here? We should have our plug. We should have our plug, which must be connected, which must be fitted. We can say, we can be very categorical. 3-pin plug in this case. So we can be able to say that's what we really need to say. Now, there are only two wires inside the cable. What are the names of the two wires in this cable? We have the earth and live, earth and neutral, live and neutral. So if you have the third cable wire in the cable, that will be the earth wire. But in this case, if we have only two, we are going to say we have only the live and the neutral wire. Use the correct answer to complete the sentence. It's safe to connect the radio to the main supply using two core cable because the radio is double insulated. Double insulated because the radio is made of plastic. So even if the user is going to touch it, is not going to get an electrical shock because it's double insulated. Yeah, the radio can also be powered by a battery. What type of current does the battery have? This is direct current only. Direct current only. So this is direct current only. We just need to move to the next part, and this next part, use the correct answer. A fuse of a fuse or a circuit breaker is connected to the wire in the circuit. This is to the live wire. This should be connected to the live wire. This should be connected to the live wire. What happens to the or what happens to cause a fuse or circuit breaker to disconnect? What happens? Yeah, what happens to cause the fuse to disconnect? This when there is too much current. So sometimes another student can say, or when there is a surge. When there is a surge of current. So any of them can work. You can just use any in order to get those marks so that you can be able to do well. Suggest two advantages of using a circuit breaker. Why do we prefer a circuit breaker to a fuse? Number one, you need to understand that a circuit breaker, once there is an excess current flowing, it will automatically switch off. So which means you cannot be replacing it now and again. Yeah, it is not replaced. Can be reset. But when we are talking about a fuse, once it blows, forget about it, go and buy another one. Yeah, it's sensitive, more sensitive or it's faster. It disconnects quite within a short period of time compared to this fuse that we can talk about here. Now we are having this section here which says that the figure shows a 3-pin plug, and then we have three different sections, and you can see this C here is connected to the fuse. Definitely where the fuse is seen, where you see a fuse, then that's where the live wire is. And so we can say the live wire is basically C. Yeah, the live wire is C. We need to put that write that down. And if you've not joined our Proflan Patreon page, just join so that you can be able to download this paper you can see here. So we are going to say the live wire is C, then the neutral wire in this case is going to be A, and B is going to be the earth. B is going to be earth. Let me tell you, you'll find that the earth is usually longer. It's longer so that by the time you are inserting, if there is the first one that's going to be in contact, yeah, so the moment it touches, and if there was an excess current flowing, it will be connected to the earth so that the person is prevented. Also, it's longer so that it can be able to open the circuit. Name the material that could be used to make the case of the plug. In this case, we can say this could be plastic, and the reason as to why we are saying it's plastic is because it's a poor conductor of electricity. It's an insulator. Yeah, we have a drill here, and we are supposed to calculate the power, but remember, power is equals to energy over time. And in this case, we are given the energy is 30 joules, so we are going to say that is 30,000 joules, divided by the time, which is in seconds here. So if we can be able to divide these guys here, we are going to say, don't want to stress up here, we just divide using our calculator, and this is going to give us 600 watts. So we are going to say this is going to get us to 600 watts. Yeah, then we are done with that. Yeah, so the second drill is used with an extension lead. The power is 1200 watts. So we have an extension here. This is an electric extension lead. Yeah, so the power is 1200 watts. Instructions are given here. When used, the lead may get hot. Yeah, the lead wound inside as 820 watts. Lead fully unwounded outside is 3100 watts. It will not be safe to use this drill with the extension lead if it's left wound inside the plastic. Explain why. Why do you think it should not be the case here? So we are going to say the reason here is that the power is greater. So the power is greater. We can say here power is greater, yeah, than 820 watts. And hence the cable will overheat. The cable will overheat, and this is going to be a bit dangerous, which can lead to outbreak of fire. So those are the consideration we have to put in mind whenever we are going to work out this. Now, a person is going to buy the drills X, Y, and Z. Use the information provided here to advise which drill this person is going to buy. In this case, we are going to consider the most efficient. You see this one is 64. Output is 500. So you can be able to use efficiency is power out over power in times 100, so that you can be able to check which one will be the most efficient. In this case, we are going to say it's going to be X, because it's most efficient. If you use the formula power in over power out times 100, you are going to get this has got higher efficiency than the rest in this case. In question number 5, what is the frequency of AC main electricity? In this case, this is going to be, we are going to say this is 50 hertz. 50 hertz. What is the power of the electric kettle? In this case, this is 2760 watts, because it really uses a lot of electricity. Now, to boil water in the kettle, 2400 coulombs of charge passes through in this particular seconds. Calculate the current. So we're going to use the formula charge is equals IT, meaning current times time. So if we want current, it will be charge over time, which will be 2400. We divide by 200, and in this case this will cancel out. We shall remain with 12 amperes as the current in this particular case. So if you've gotten value from this particular video, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. See you in the next tutorial.